Okay, don't get mad at me. I know I said that was the last example. This is not an example. This is a trick. Stay tuned if you want to know a good way to get around doing least common multiple. Don't forget how to do least common multiple, but here's a way that you can avoid doing it. Okay, if you're having trouble with that, if that's just complicated, if it makes the process way too long for you, here's a shortcut. Call it that. And I will tell you when it works and when it does not work and when you should use the least common multiple trick. So, we have two fractions, we are comparing them, or we could be adding or subtracting. Not that we're adding and subtracting fractions yet, but that should know that. That should be last year's stuff. But if you don't remember how to do that, then we'll get there next week or something. So we have two fractions. Let's say we're comparing them. We can't compare them unless we have a common denominator. And we don't have a common denominator between 5 and 4. So here's what we're going to do. This is called the butterfly method. I will make wings of a butterfly. It doesn't look very much like a butterfly, honestly, but it works for what the purpose is intended. So we've got the wings of the butterfly, and we have the antennas of the butterfly, and we've got this little thorax abdomen thing, the end of the butt of the butterfly, I guess. Butterfly. So, and over here we've got these fraction bars. Call them legs or something, I guess. Now, that's what it looks like when you're doing it. This could also be a little multiplication symbol down here. What we're doing is finding our common denominator without listing out the denominator's multiples. So we're just going to multiply straight across here. 5 times 4, 4 times 5, and we're going to get 20 on both sides. And there we have our common denominator. And now instead of saying 3/5 is equal to how many 20ths, we're just going to go, okay, well, we multiplied this by this. We must need to multiply our numerator by this. So up the wing and over gets me 12. Same with the other side. Up the wing and over gets me 15. And now I've got 12/15 and 15/15, and I can easily compare these guys. 15/15 is bigger. I could easily add them. That would be 25/20ths, which would be 1 and 5/20ths, which is 1 and 1/4 if we simplify. That was too fast and complicated. Don't worry, I'm going to do it again. So, we have two fractions, 5/8 and 2/3. I will draw my wings. One numerator, one denominator on each wing. One numerator, one denominator on each wing. My little antennae pop out to the side, and I'll put a little X here to know that I'm multiplying these guys here, and my fraction bars on either side. Now, 8 times 3 is 24. 8 times 3, 3 times 8 is 24. What I did to the bottom, I'm going to do to the top here. 3 times 5 up the wing and out gets me 15. 8 times 2 up the wing and out gets me 16. This one's bigger. 2/3 is larger than 5/8. I could add them together and get 31/24, etc. I could subtract them and get 1/24. Regardless, I have my common denominator, and I didn't have to set up my equal sign up here for this equation and find the missing number. Now, I said I'd tell you when it doesn't work very well, and here's one. 24 times 12. I don't really want to do that, because that would get me, I'd have my wings here. I'd have to do 24 times 12, when I can just look at this and go, oh, wait, I know what the common multiple here is, because 12 times 2 is 24. So I would just have to multiply this fraction by 2, which I will do in blue since the green is there, times 2, times 2, and I would get 6/24. Oh, look, these guys are equal. Okay, I didn't have to do any of this, because I know that 12 times 2 is 24. I know my least common multiple here. Okay? I'm going to do this one more time. So like if I have really big numbers, if I have really big fractions, like really big denominators or really big numbers within my fractions, I don't really want to do this butterfly method, because then I'll get some wacky multiplication. I'll spend more time doing multiplication than I would listing multiples. So one more time with the butterfly. Make my wings to encompass one numerator and one denominator in opposite fractions. I'll put my X. and my antennae. Straight across the bottom, 7 times 5 is 35. 35. Up the wing and over to get me the same thing I did at the bottom, I did at the top. Up the wing and out gets me 25. Up the wing and out on the other side gets me 21. And it looks like 5/7 is bigger than 3/5. And that's the butterfly method. If this works for you, then by all means, you're welcome to use it whenever, okay? Welcome to use it. If you prefer this method, 7, 5, 7, 14, 21, 28, 35, 35, 5, 10, 15, 20, 25, 30, 35. Look, found it. And then setting up my equal fractions, 5/7 equals how many 35/5, and 3/5 equals how many 35ths. I go times 5, I go times 7, etc. If this way works for you, then use this way. I'm not telling you to use one way or the other, I'm just giving you another method. If this way doesn't work for you, if you're too complicated on this, if this confuses you, then use this. If this wacky diagram confuses you, then use this. This works for adding, subtracting, and comparing and ordering fractions.